Alright, Algebra 2, target 16, I can determine if an integer is a solution of a polynomial equation. Okay, so we're going to talk about the factor theorem. So, suppose you have a polynomial f of x, and you divide it by factor x minus k, right there, and you get your quotient and 0 as a remainder. That means you can ignore the remainder and you just have the new function q of x. So basically q of x is equal to f of x times the factor x minus k that you divided by, and x minus k is a factor of f of x. So that's a couple ways that you can make a conclusion from the factor theorem. And to sum that up, so a polynomial f of x has a factor x minus k if and only if, meaning that one doesn't happen without the other, f of x is equal to 0. Alright, the factor theorem also tells us that a 0 and a factor are the same thing and a solution. So if I have a factor x minus k, and I set that equal to 0, so x minus k is a factor of the function, and I add k over, x equals k is a 0 of the function, and it's also a solution of the function. So that terminology, these are interchangeable, and the factor is just how you convert from the factor to the solution. Okay, which means that we can do synthetic division, putting our k in the box to determine if an integer is a solution to some polynomial equation f of x. So here we have an example. Determine if x equals -2 is a solution of f of x equals 0 if f of x is 3x cubed minus 4x squared minus 28x minus 16. So this up here tells us we can use synthetic division using our k, our solution, so -2 in the box. So I'll put -2 up there. And then remember, for synthetic division, we use our coefficients of our function and making sure that we're checking for holes. So we go 3, 2, 1 constants, so we don't have any. So we just put our coefficients like so, and we divide. So we bring down the 3, multiply by the box, get -6, add to get -10, multiply by the box to get 20, subtract to get -8, multiply by the box to get 16, and we get a remainder of 0. So this remainder here tells us that, if you remember over here, if we get a remainder of 0, it means that x minus k is a factor of f of x, and if x minus k is a factor, then x equals k is a solution, so -2 is a solution of f of x in this case. Alright, another example, so determining, now we have 3 solutions that we're going to decide if they are solutions to f of x equals x cubed minus 2x squared minus 23x plus 60. So I'm going to try each of these, x equals 1, x equals 2, and x equals 3, using synthetic division into f of x. So I'll put 1 in the box, because 1 is my, that's x equals k, 1 is my k, and then I put my coefficients of my function here, making sure I check for holes, and I do synthetic division. Minus 2 is -1, times 1 is -1, -24, 60 minus 24 is 26?
36.
36. Alright, so since 36 is not 0 and we have a remainder, that means that x equals 1 is not a solution. Alright, pause your video and see if you can figure out if x equals 2 and x equals 3 are solutions by using synthetic division. Okay? So to check if x equals 2 is a solution, we put 2 in the box. And we use our same coefficients. So I'm going to bring that 1 down, multiply it, you get 0, 0 to 0, negative 23, times 2 is negative 46, and 60 minus 46 is 14. All right, 14 does not equal 0, so 2 is not a solution. All right, then we're going to try the last one, x equals 3. So you put 3 in the box, use the same coefficients. Bring down the 1. 1 times 3 is 3, minus 2 is 1, 3 is 3, negative 20, negative 60. Now we have a remainder of 0. So that tells us that 3 is a solution. So x equals 3 is a solution of f of x. Alright? Alright, so now because a factor, a 0, and a solution of a polynomial are closely related, we can use them to kind of talk about the same things. So if you're given one factor, you can find the other factor. So if you're given x minus k, you can find any other factors. Remember, x minus k equals 0, because factors and zeros and solutions are the same thing. X equals k. So then I can use synthetic division with my k and find other factors, and I'll show you how to do that in one of the next examples. And then same thing, what we just did in the other one, we find, given one 0, we can find the other zeros. Given one solution, we can find the other solutions. Alright, so now given, so that what this first one here is talking about, given that we have the factor x minus 3 of f of x, we can use our synthetic division to find all the other factors, so factoring the polynomial completely. So I'll use the fact that x minus 3 is a factor and a solution, set that equal to 0, so I get x equals 3. So 3 is my k, so I'll use that in the box. Then I'll put the coefficients of your function. Bring it down. 1 times 3, 3 plus 2 is 5, times 3 is 15, minus 9 is 6, times 3 is 18, 0. So if you remember from the very first slide, this function we get, which should be x squared plus 5x plus 6, times what we divided by, that factor x minus 3, is equal to f of x. So we just found another form of factoring a polynomial function. Alright, but we are not finished, because this here is a quadratic expression, so we can put it into our box to finish factoring this part of this equation. So I put my first term there, my constant there, and I need to split up the middle term and this box. So I'll have x to find those coefficients, find what multiplies to 6, adds to 5, that would be 3 and 2, both positive. So I'll stick them in there, and then I'll factor it out. Here we have a 2, here we have an x, and a 3. So this right here factors into x plus 2, x plus 3, and then don't forget to also include that factor as well that you started with. So now the original function f of x factors into these 3 factors. So we have now found all the other factors of f of x. Alright, so in conclusion, if you're determining if a factor, x minus k, or if a solution, x equals k, are a factor or solution of f of x, remember that you can convert x minus k equals 0 to x equals k, and then you will synthetically divide using your
Continue.
Alright, then you put k in the box and synthetically divide. If you get a remainder of 0, that means yes, it's a factor or it's a solution depending on what you're given and what you're asked for. And then if you are given a specific factor or solution of some function and asked to find all other factors or solutions, you'll also synthetically divide, remembering that you can turn a factor into a solution to get your k. You put your k in the box. Then, like the one example, you're going to factor what's left, that quadratic equation. Then those factors you find, plus the original factor, x minus k you're given, will give you all the factors to f of x. And if you need the solutions, you can set each one equal to 0 to find the rest of your solutions for k.